Good morning. So in this lecture, we will see about statistical quality control and how do you do by control chart. So any control chart, basically there are two things it will do. So first thing is we have to find out whether the manufacturing process or whatever may be the process, whether it is stable. In other words, we will find out whether it is, we are going to use about whether it is in control. That's why it's called control chart. So whether the process is in control or out of control. That is stability. Basically, we are going to see whether the process is going to be stable. And the number two is, in case of control chart, we are going to see if at all it is out of control, we will tell what is the assignable cause. What is going to be the cause. So whatever cause and effect diagram we have seen, whether it is due to the operator or whether it is due to the environment or whether these are all some of the usual causes. Material, weather material. So all these things we will find out from the control chart. So before going into the control chart, let me brush up something about statistics. So because this control chart is based on stats, it is called statistical control chart. So this statistics we will summarize whatever you have learned previously, how we are going to use in TQM. So that's what we are seeing. So the statistics definition I'll read from the textbook. It is defined as the science that deals with the collection, tabulation, analysis, interpretation, and presentation of quantitative data. So we are going to collect data. So when it comes to TQM, how do you collect the data? So we will have various means. Many operator know all the defects in any industry. All data will be available. All data will be available, weather inspection data, all these things. The data in case of industry, it will be recorded. All these data will be required. So we are collecting the data. Next, we have to tabulate the data and then analyze the data. And analyze the data, we are going to use the various statistical techniques. Then we are going to interpret. So how do you do? So I will just give we will start with an example, and then finally we are going to present the data. Before going into the control chart, for example, I'm giving you, so there is a batsman, I'm giving the scores for his 10 innings. So the first one, because I cannot write here, I'll try if I can write here. Just I will write 240, 230, 230, 0, 0, 0, 0. Okay. So this is the data I have given a batsman. He has scored 240 runs, 10 innings. So that's 10 innings. So just for you to understand, this is the data. Just for you to understand the various statistical parameters, I'm giving this data. So 240, 230, 230, 0, 0, 0, 0, 0, 0. So 10 innings I have given. And the idea is whether he is a good batsman or not a good batsman. So you might have studied about statistics. So you might have studied, there is something called average, or sometimes we will use the word mean. Average, mode, median, range, and then standard deviation. So these are the 5 things. Based on this, we have to analyze. So first, if you take the mean average, so in this case, 240 plus 230 plus 230, so it is coming around 700, and I am going to divide it by 10 just for simplification. So 240 plus 230 plus 230 is 700. I am going to divide by 10 innings, and the average is 70. So you know very well, a person who knows cricket, he will tell 70 is a very good average. It's very idealistic. So normally, of course, I have given this for only 10 innings. If somebody is playing for 50 test matches, and if he's an average of 7, I think nobody even The all-time great Don Bradman is also having an average of 50, and even our own all-time great Sachin Tendulkar is also having an average of something around 50 plus. So this batsman is having an average of 70. Now we are having only data for 10 innings, and based on average, we can very well tell he is a very good batsman. He's a very good batsman. So somebody is having an average of 70, he is a very good batsman. So whenever you have this, what do you call it, mean, that is average, when you're considering the average, but that alone is not going to give the factors. Next, if you see median. So what is a median? So all this data you arrange in order, ascending order. So there are 7 zeros, and then you will have 240, 230, 230. And of course, this is not going to give a good picture in this place. So because you are going to get 0. So this is so I'm going to arrange all the 10 data, whatever we are having. If I am arranging in ascending order, 230, 230, 240 will come in the end. So in case of median also, the average, the thing is median is going to be 0. So it is giving a very different picture. But I again taken data like this, median. And then mode, if you take the mode, 0 has come 7 times, whereas 230 has come 2 times. That is, mode means repeatedly. So here also, this is not going to work. So whenever we are going for statistics, there are 2 important concepts. One is called measure of central tendency, and the other one is called measure of dispersion. So both have to be considered. So listen to me carefully. So these 2 measures, so whenever you go for statistical, the first one is called measure of central tendency, that is called average or mean or mode. And the second one is we have to consider the measure of dispersion, how the data is dispersed around the average. So for that, there are 2 things. One is called the range, and the other one is called the standard deviation. These 2 things. So from this data, you will understand very clear, average is not going to give the good picture. So you know this case, the average is 70, and you know very well from the data, even though the average is 70, this batsman is not a good batsman. Probably he has scored 240 against a country like Afghanistan or Zimbabwe, or maybe we can include Sri Lanka also, because Sri Lanka has won World Cup once, but now we can say he has scored around 240. If this batsman is allowed to play against South Africa or Australia, he is going to score. He is going to score something like this. So this is what assignable causes. So we have to analyze. We have to analyze that. So that is the stage we are seeing. So from data, first step, statistic, we are collecting the data, tabulating the data, and then we are analyzing the data, interpreting the data, and finding out the assignable causes. Interpreting, and then finally we are giving the data. So this is of interpretation, and I'm giving the assignable cause. So he's going, whenever he is asked to play against South Africa, he will score this score. And whenever he is asked to play against Zimbabwe, he will score this score. So these are the various ways, same concepts we are going to use in control charts. So if you, how the basic, whenever you have the data, you try to plot the average. From the average, whether how many scores are away from the average and how many scores are near the average. For that, we require these two. So these are called methods of, measure of dispersion. Measure of dispersion, that is range and standard deviation. So how it is moved. So for that, you know about the Gaussian distribution, and you know very well that bell-shaped normal curve. I don't know mathematics, how many of you remember? So it will be from the average, the bell curve will be something like this. So this line is the central line, that is the average. So this is the average, and how the data, for example, if you plot this data, the average is 70, this 240, 230 will come here, all the zeros will come here. So entire thing about TQM, I'm telling, the variation should be minimized. So as we go in, I'm going to tell also. So this is this center. This is the standard. For example, this is the standard. The average in this case 70. Ideally, all the data should be grouped near that 70. So you should have scored 69, 67, some few hundreds, few 200s. And this side also, everything should be close to the average. So if you are having an average of 70, if all the scores are near 70, then he is a good batsman. But in this case, you see all are in the extremes. So that's why we are thinking. So how the measure of dispersion, how the data is dispersed around the average. So in the bell-shaped Gaussian distribution, you know, this is the average. This is the average. Around the average, all the data should be dispersed. That should be the idea. The entire TQM, even in the, if you remember first class itself, I'm telling you, the concept of TQM is you minimize the variation. You minimize the variation. So why variation is happening? There are some 3 or 4 reasons why this variation. So I'm reading from the textbook. Within the component, there can be variations. So for example, I don't know whether this 19 BME students, whether you have used the late. I know very well because I was teaching manufacturing at the time. We had COVID, and you have seen only videos. Of course, you can see in YouTube also. So whenever you manufacture a component using a lathe, within the component, the surface finish. So the quality characteristics is very, in this case, is surface finish. So the surface finish will not be same. If you metrology, I don't know whether the 5th semester you studied, for your batch I have not taken measuring metrology. So the surface finish will not be the same throughout the component. If you measure now, some variation will be there. So within the component, the quality, so this is TQM. The quality characteristics is here. In this case, it is surface finish. So the surface finish will not be uniform within the component. That is number 1. The number 2, piece-to-piece variation. So this is the good example to understand this variation concept and control chart. So if you take piece-to-piece variations produced at the same time, suppose if you are taking 4 bulbs, consecutive bulbs, they are manufactured at the same time, and if you measure their intensity, the light intensity of 4 the bulbs, and I don't know, by common sense, you will tell they will not be same time we are manufacture the same equipment, because most of the light they will be automated. Mostly the operator influence will be very less. The same machine we are using, consecutively we are producing same 4 bulbs, and if you are measuring the intensity, there will be piece-to-piece variation. So the main idea of this total quality management is it should not be the same. So there is something called here, the quality characteristic is light intensity. So the intensity should be uniform, and there is a standard. It should not be very bright, or it should not be very dull intensity. If the intensity is very high, consuming of electricity, even though it is fine, but consuming electricity. So there is a standard. There is a standard some intensity, and always it should be near that. That means indirectly it should not be, the intensity should not be very high, or intensity should not be very low. The intensity should be around an average. So there is a standard. So here the quality characteristics. So this is called piece-to-piece variation. So within the piece variation, the example is surface finish. Piece-to-piece variation is this light bulb, intensity bulb. The third one is time-to-time variation will be there. So, for example, the operator morning 8 o'clock. Now the company starts at 8 o'clock. The operator will be, the worker will be fresh. For example, it's a manual lathe. Suppose it's an ordinary engine lathe. Normally use the word engine lathe. So previously it was engine, now motor is there. Engine lathe. Morning 8 o'clock, the worker will be very fresh, and he will be able to do good job. The surface finish will be good. The accuracy will be very good. End of the day, now 8 o'clock the shifts are, normally India the shift will be 8 hours. If you go to Singapore, I was surprised, they are all working for 12 hours. So if it is 8 hours, now morning 8 o'clock means 4 o'clock shift will be over. So 3:45, if you are measuring, the accuracy will not be very good. So the same example, even if you take, so now I am teaching 8 o'clock, I came fresh to the class. Because of some reason, because we now MTech students classes have started, I have to start the class at 8:25. But I am very fresh. I am able to talk, no problem, because I came. Now the other subject which I am taking is integrated manufacturing system for first year MTech. And you see that first year MTech, now only the classes have started. It is going to go up to May 30th, up to May 15th, up to May 30th. So assume May 15th, I am going to take class. And it is in the afternoon slot. TQM is in the morning slot. That is in the afternoon slot. So 2 o'clock, one class is there. The other class is at 3 o'clock. So 2 o'clock. And another thing is now I am in the comfort of my cabin. And that I am sitting and taking class. Whereas in case of this integrated manufacturing system, 2 o'clock, that means 1:45, I have to start from my cabin. And I have to go to something called health center back. I don't know whether you have seen health center. So it is on the other side. Right now, I'm in the academic block 1. That is in the other side health center. It is near to the academic block 2. And for me, it will take minimum of 10 minutes to walk. And of course, it is in the first floor. And I have to take the class. You see, 2 o'clock, May 15th, I think all of you know Chennai weather. So there is a difference. There is a difference. So that is called time-to-time variation. Time-to-time variation. So what you must, from all these examples, whether it is within the piece variation or whether the piece-to-piece variation, whether the time-to variation, all these variations, TQM, what it says, it has to be minimized. It has to be minimized. So first thing is we should have data. We should know whether the process is in control. If all the variations is minimum, the variations is minimum. If the variation is minimum, means it is better. It is better. It is better. And if that is the main idea. Okay. So now how to go for assignable causes? Assignable causes. So there are 4 reasons for the source of variance. Important reasons are taken. There may be many reasons. There are 4 important reasons. So the first one is equipment. That is basically if something goes wrong means because of machine. That is very obviously common sense. Machine vibration is there. For example, surface machine will be very poor. So equipment, there will be variation due to equipment. Second variation is due to material, because the material what we are getting is a finished product for other company. So that material, environment, and then operator. So we have to give the assignment. So interpretation is very important, because many times control chart, no, you know how to plot. First time when I was teaching this TQM subject, first time I was during COVID. Because this is the second time during COVID I'm teaching, and probably it's the last time. Next time it is going to be offline classes. So during COVID, at the time I was given this subject, and at the time Code Chandra was not there. Only for the FAT exam we had Code Chandra. I allowed the students to do using Excel. So using Excel, I asked them to do these things. So all these things they plotted. Only thing everybody did, because it's very simple Excel how to find. But the only thing, interpretation, there is going to be a problem. But so how all these equipment, materials, environment, operator, all these things, so we have to. The range is what meant the maximum dimension and the minimum dimension. That is difference is going to be the range, and then standard deviation. So how do you find out the standard deviation? X minus X bar sigma whole square divided by n minus 1 will give the standard deviation. So for example, this CAT1 examination, I have found out the standard deviation and the average. So for this, from this CAT1 exam of this TQM, there are 76 students, and the average is 20 out of 30. Out of 30, the average is 20, and the standard deviation is 3.59. So always please remember the standard deviation, the lesser means it is better. So we got 3.5. I got for this CAT1 test, there are 74 out of 76, 2 students are absent. So 74 students wrote the exam, and the average I got 20 out of 30. That is around 67%. 67%, and the standard deviation is 3.5. And please remember, the standard deviation, smaller the better. The deviation should be lesser. That means indirectly the variation should be less. So that is about the variations. So now, how to find out? So data used in the control chart. There are 2 charts: X bar chart, R chart. And the another thing you must understand is, for example, we have taken a data where everything is finite. For example, if you take a batsman like Virat Kohli, if you want to understand all the things, we can find out all the scores. He has played for some around 200 innings, so we can find out all the scores and other things. Now, sometimes it may not be possible to analyze the data. So where you have a population where the number is quite high. So for example, if you take a batsman, you would have played for some 120 test matches. So all these things, even in Excel sheet, we can find out, and we can find out how yes, what is his average, how is variations, all these things we can analyze easily if the data is finite. If the data is population is huge, so we have to take a sample. And we have to analyze the sample. So how do you take the sample from one shift to collect the data? And we can. So for that, we have two types of thing. One is called variable control chart. Other one is called attribute control chart. So what is that variable? Suppose if you measure something, that is going to be variable. So for example, if you measure the weight, it is going to be so many grams. If it is dimension tolerance, it is millimeter. So if it is measurable, it is called variable. That is called variable control chart. Sometimes you need not measure. We want to find out whether it is acceptable or not acceptable. For me, I'm not bothered whether if I measure whether it is 25.03, 20. I'm not worried about measurement. I want to know whether it is acceptable or not acceptable. So for that is called attribute type of control chart. So if it is measurable, if the quality characteristic is measurable, it is called variable control chart. If it is not measurable, it is called attribute control chart. So the best thing to understand this attribute is, so we want to know whether it is acceptable or not acceptable. That is whether the part what we are making, whether it is acceptable or not acceptable, that is called attribute. So for example, if you take a shaft like this, so you have a shaft, what is the diameter? Now you make a gauge, that is, you make the hole. You make a hole like this. So this is the product. This is the component. This is the part. Now this diameter. Now this whole diameter, if I am making it as 30.1, if it is, for example, the diameter is 30 mm, the rod diameter is 30 mm. So if you keep like this, 30.1, if the diameter of the hole you keep 30.1, now the component will go inside. The problem is the oversized cannot go. So this is 30.1. For example, the hole size is 30.1. For example, if the shaft is 30.2, the oversized cannot go. It cannot go. So this is a go gauge. But the undersized component, for example, 29.1, for the diameter of the part is 29.1, it can go inside the hole. So this is a go gauge. So if the component goes inside the gauge, then it is called go gauge. And the same way, no-go gauge, whatever, this dimension, you keep it as 29.5. So you keep the whole 29.5. So anything above the 29.5 only can go. So this is called no gauge. It's called no gauge. So the idea is we can get the products from 29.5 to 29. If it is still lesser only, it can go to 29. So that means undersized. Whatever no-go gauge, whatever goes inside, it is undersized. So we have to see whether it should not be oversized or it should not be undersized. It should not be correct size. So our idea is not to measure. So we have a go gauge. So if the component dimension, if it is properly sized, it can go inside. It can go inside. So no gauge, it should not go. So here the whole dimension will be lesser than the shaft dimension. So that is called attribute type of chart. Now the data used in control chart, X bar and R chart. So R means range, X means average. So from Gillette example, 15 hours become 15 subgroups. So we have data like this. So here, this is the Gillette. I think it is mm, measurement is mm. So you see, so there is the data, first hour, second hour, 15 hours, and 5 subgroups, 5 measurements for each group, each subgroup. So this is first hour, 5 measurements. So there are 5 measurements, 0.62, it is mm, 0.625, 0.66. So first hour, there are each subgroup, we are having the measurements like this. So we have to find out X bar average. Range is nothing but maximum minus minimum. Average means sigma. You have to add them and divide by n, where n is 15, in this case 15. And then find the mean of x bar and range. And range, we are finding the average of mean and other. So what I'm doing, first hour, mean of each hour. I'm adding them, add all the time, and divided by 5. The range is maximum. Maximum 0.62667 is the maximum. Minimum is 0.624. So the range is this much. So this way we have to, so instead of mean of the mean, everything we can find it. So with this, I will stop for this class. So Wednesday, I will explain how to plot the control chart. And then we will discuss whether how the process is out of control or in control. So quickly I'll show the slides. The control chart will be something like this, X bar control chart. We will have the mean line and then the data. The x-axis subgroup. We have the data and out, whether the process is out of control and out, whether it is in control, we can say whether the process is stable. And the next stage, we can find out what is going to be the assignable causes. So you have the chart, you have the control chart like this. So we have to assign the causes. For example, if it is in the time means, we can say the operator problem is their operator problem. So we can say this type of. So we can give some assignable cause based on this pattern. We can give this. So with this, I will stop for this class. On Wednesday, 8:55, we will have control. We will continue our discussion on control charts. And another thing I want to inform you is I have displayed the marks. You can see your marks. Cat1 marks, Code Tantra, I have enabled. So please, any one of you, please confirm whether you have seen your marks.